So now let us talk about trigonometric ratios of complementary angles. Yeah, you're right. Let us talk about trigonometric ratios of complementary angles. First of all, before moving to that, you should be very clear what do you mean by complementary angles. This is a basic concept that you might have studied in your earlier classes, but still let us recall that if two angles sum up to 90 degrees, then those angles are known as complementary angles. So for example, if I have two angles theta and phi, and if theta plus phi is equal to 90 degrees, then we say that theta and phi are complement of each other. That is the basic concept of complementary angles. So now we'll be seeing how the trigonometric ratios vary, how the trigonometric ratios are defined for complementary angles. Let us take a simple case of a right angle triangle ABC. This is A, this is B, this is C, right angle at B. Say this angle is theta, so and this angle is phi. Okay, say this side is x, this side is y, and this side is z. Now, if I'll ask you, now see this, you know that sum of angles of a triangle is always equals to 180 degrees. This angle is already 90. So can I say theta plus phi is equal to 90 degrees, right? Because this plus this 90 and this 90 total sum 180 degrees. Hence theta plus 90 is theta plus phi is 90 degrees. Hence this implies theta and phi are complementary angles, right? So I can write phi is nothing but 90 minus theta. Okay, now let us talk about trigonometric ratios of theta. I know that sine theta, perpendicular by hypotenuse with respect to theta. Now with respect to this theta, my perpendicular has a length of y and hypotenuse has a length of z. So sine theta becomes y by z. Similarly, cos theta becomes base by hypotenuse, that is x by z, and tan theta becomes perpendicular by base, that is y by x, and similarly other three trigonometric ratios can be defined. Now let us talk about phi, right? Let us talk about this angle. If I'll ask you, what is the value of sine of phi? Now just try to visualize this triangle from the point of view of angle A. With respect to angle A, this will become my perpendicular, BC will become my perpendicular, and AB will become my base. So sine of phi will become perpendicular by hypotenuse, that is x by z. Similarly, cos of phi will become base by hypotenuse. With respect to angle A, this AB is my base and AC is my hypotenuse. So this becomes y by z, and finally tan phi perpendicular by base, that is x by y. Clear? So now I think that the trigonometric ratios for theta and phi separately are clear to you. Now let us see how we can relate the trigonometric ratios for theta and phi, and we know that theta and phi are complement of each other. Sin theta is y by z and cos of phi is also y by z, right? Agree? Sin theta is y by z and cos theta is also y by z. So I can say that this and this are equal to each other, right? Similarly, cos theta is x by z and sin phi is x by z. So this and this are equal to each other, right? Now let us see. So let us equate sin theta and cos phi, because I know that sin theta is y by z and cos of phi is also y by z. So sin theta became equal to cos phi. So from here I can write sin theta is equal to cos of phi. But what is phi basically? 90 minus theta, right? So from here I can conclude that sin theta is equal to cos of 90 minus theta. Our first concept of complementary angles, that for two complementary angles the sin theta and cos theta related in such a way that sin theta is always equal to cos of 90 minus theta. Similarly, check out this, cos theta is x by z and sin phi is x by z. So I can write cos theta is equal to sine of phi, which means cos theta is equal to sine of 90 minus theta. For two complementary angles, sine and cos are again related in this manner. Similarly, you can conclude about other trigonometric ratios that tan theta is equal to cot of 90 minus theta. How can you visualize this? See this, tan theta is y by x and tan phi is x by y. Basically 1 by tan theta, and 1 by tan theta is nothing but cot theta, right? Or agree? So I can say this tan theta, and for this phi, tan phi became equal to cot theta. So if I'll say tan of phi is equal to cot theta, this implies tan of 90 minus theta is equal to cot theta, and tan theta is equal to cot of 90 minus theta. So these are the four ratios that we got. Cot theta is equal to tan of 90 minus theta. And last two we can conclude, sec theta is equal to cosec of 90 minus theta, and cosec theta similarly will be equal to sec of 90 minus theta. So this is how we can relate the complementary angles of the trigonometric ratios of complementary angles. And you can see while our derivation also, suppose let us take a basic example of 30 degrees and 60 degrees. I know that 30 and 60 are complement of each other. Sine 30, the value of sine 30 is root 3 by 2. Now this should be equal to cos of 90 minus 30, right? This is what we learned now, which is equal to cos of 60. Sorry, sine 30 is not root 3 by 2, sine 30 is 1 by 2, and cos 60 is also 1 by 2. Similarly, if I'll try to write sine of 60, sine 60 is root 3 by 2, which should be equal to cos of 90 minus 60, that is cos of 30, which is again equal to root 3 by 2. So this is how you can relate complementary angles using the given set of relations.